Welcome back to another demo. Today we will be showing you the ride analysis page. So ride analysis at Applied Racing Dynamics is a virtual four-post rig. A four-post rig is a way for engineers to sort of isolate the suspension response of a system and analyze its behavior. We've seen customers use the ride analysis page to improve their damper settings as well as their spring configurations for the race circuit. Now, let's see it in action. Let's start by selecting some input signals. We have a range of predefined options to choose from. We have the chirp signal, noise, step, impulse, but also fully custom signals defined in the table, which we can just copy and paste from a spreadsheet. The best part? You can apply different signals to each wheel. For example, let's apply a 1 mm amplitude chirp to the front wheels and a 2 mm amplitude chirp to the rear wheels. Once that's set, we can preview the inputs and see both signals applied exactly as we want. We can also save the input configuration for later use. Next, we give this simulation a name and send it to the cloud. Depending on our signal complexity, a simulation will typically complete in around a minute. Once the simulation is complete, we can pull up the results from our saved simulations library and compare multiple setups side by side. This is where the real insights happen. At the displacement page, here we can see the vertical displacements of the vehicle body and each wheel corner. The RMS values give us a single number to quickly compare ride quality across different setups. Lower RMS means less variation. This can be beneficial for a stable aerodynamic platform, driver comfort, or even better tire contact with the surface. If we're interested in natural frequencies, we can switch to this view for a detailed breakdown. Here, we can see how the system responds across different frequency ranges. Those peaks you see, those are the natural frequencies of your suspension system. We can also spot general magnitude shifts that tell us how the suspension filters different inputs. Finally, the distribution page. This shows us how damper velocity is distributed during the simulation. We're looking for a bell-shaped curve. This tells us the damper is working effectively in both compression and rebound. If the curve is skewed or has multiple peaks, it might indicate our damper curves need adjustment. Running ride simulations has never been easier. Head over to appliedracingdynamics.com and run your first ride simulations today.